This is a quick video where I'm going to look at probabilities in a normal distribution. If you want more information about normal distributions, please look at my notes or other YouTube videos where I introduce this concept. I also have another video where I calculate a value corresponding to an area. In this problem, we are just going to take the standard operation with normal distributions, and I'm going to use a mean of 120 and a standard deviation of 5. So say, for example, I wanted to find the probability of finding an individual outcome that's above 132. What I'm looking for is the probability that x is greater than or to the right of 132. So this is using function notation, and the input here is not the traditional just plug in a number for x. We're actually saying, shade to the right of 132 and find the probability. So all we do for Stapplet is go to the right of 132 and see what that area is. If you need to adjust your rounding, you can change it between percents and decimals and the number of digits of precision there. So this is 0.0082 or 0.82%. This is approximate, it's not exact, but that is the best way we would use that notation. We could also find the probability of being below or to the left of that value. That would just be the complement. The entire area should add up to 100%. So if we shade to the left, we get the complementary probability, 0.9918. Or 99.18% of observations will be under 132 in this population. Lastly, I could find a probability of being between two values, say anywhere from 109 to 132. We can see 109's here, 132's here. That would be in between these two values. And so we actually have two z-scores, one for the left number, one for the right number. Probability of being between those two z-scores, same as the probability there, 0.9779. So that's all I would need to do for those. In each case, you do get a z. And just keep in mind that when you know z, you can break that down to just your standard normal distribution. I believe it was negative 2.2 to 2.4 for that, and then that exact same, we're going to see nearly the same picture. It's just now we've standardized this to just number of standard deviations. But otherwise we get that same result. So that's why it's telling you that z. Z is kind of like a secret code just to figure out where you are on that curve. Not in terms of numbers, but just in terms of how many standard deviations over are you on either side.